Good morning and welcome to this webinar on Provision ISR Analytics. I'm Ari Trieger, a representative from the Pre-Sales Division at Provision ISR, and I appreciate your presence here today. During the next 45 minutes, our focus will be on an in-depth exploration of the analytics solutions provided by Provision ISR. As we navigate through this session, I'll be presenting a comprehensive overview of the diverse analytic tools at your disposal, demonstrating their capabilities and the value they bring to your security infrastructure. This webinar has been designed to be efficient and informative, ensuring that your time is well respected. By the end of our time together, you'll not only be familiar with Provision ISR Analytics, but also equipped with insights into their practical applications for enhancing security measures. Thank you for joining us, and without further ado, let's delve into the realm of Provision ISR Analytics. At Provision ISR, we take immense pride in our analytical prowess. We dedicate numerous hours to research and development, constantly pushing the boundaries to elevate the capabilities of our analytics. The consistent positive feedback from our clients speaks volumes about the substantial reduction in false alarms we've achieved. Before we delve into our analytics, let's trace the evolution of this field. We began with pixel-based analytics, known as VMD, or video motion detection. VMD identifies anomalies in frames by scrutinizing color differences in nearby pixel groups, commonly utilized in analog and more affordable IP systems. While cost-effective, the drawback lies in its accuracy, making this analytic prone to false alarms. Advancing further, we integrated AI into our cameras and NVRs. AI processes algorithms, enhancing the system's capability to detect specific objects and respond accordingly. AI analytics proved notably more accurate than VMD. At Provision ISR, we've crafted our proprietary analytic known as DDA, which stands for Detect, Distinguish, and Alert. DDA can differentiate between humans, vehicles, and two wheels like motorcycles or bicycles, relying on line crossing or sterile area parameters. Object counting is also within its capabilities, a topic I'll touch upon later. Taking a step into the future, we introduce our second-generation DDA analytic, accompanied by metadata. Our AI can discern object details and store this data, facilitating event searches based on specific object criteria. For humans, we can determine the gender, age group, clothing color, sleeve length, and even whether glasses are being worn. When it comes to both four- and two-wheel vehicles, we ascertain the vehicle's color, type such as pickup truck, bus, or motorcycle, and can even identify the make, such as Lexus, Nissan, Toyota. Next, I would like to discuss the analytics that Provision ISR has to offer. Please just bear in mind that I'll be delving deeper into some of the analytics later in the presentation, so I may not spend much time explaining each point on the current slide. As we just discussed, we have our first-generation DDA consisting of sterile area and line crossing, as well as our second-generation DDA that brought us metadata on human four-wheel and two-wheel vehicles. Object counting automatically tallies the number of objects passing through a specific area or line, objects being human, four-wheel, or two-wheel. Allow me to provide a practical example of its usefulness. Many shop owners or retail stores deploy this technology to count the number of people entering a store. With this data, they can determine peak hours during the day or week and adjust their workforce accordingly. When paired with our VMS, we can achieve occupancy control, crucial for establishments with limitations on the number of people allowed at any given time. We can count entrances and exits, offering a live update on the number of people inside a building, setting thresholds, and triggering notifications or reaction. Beneficial for parking management as well, vehicle counting at entrance and exits can also be monitored. Moving on, I will discuss face detection, and face recognition in more detail later, along with camera tampering. I'll elaborate on object missing and appearing. Essentially, we can set an area in the field of view and state that if an object suddenly appears or disappears, we'll get a trigger. This is particularly useful in places like art galleries, where sterile area can be defined around an artwork, and any disappearance of that art, we can notify security. Later in the presentation, we'll cover topics like loitering, audio exception, and illegal parking. We'll delve into heat mapping, combined alerts in more detail later as well. License plate recognition and gate opening, paired with a license plate recognition camera, can recognize or detect a number plate against a database. Depending on the database rules, this can open a gate, trigger security, or notify authorities for effective parking lot management. The next two analytics, fire detection and temperature monitoring, are facilitated by our thermal camera. Fire detection identifies the presence of fire within a designated area, while temperature monitoring can check temperatures in designated zones. Each zone can be set with its own predefined rule and reaction. For example, we've used temperature monitoring in a server room to notify the manager if the temperature exceeds a certain threshold, or for monitoring machinery in factories to see if they overheat. As you can see, we offer a comprehensive range of analytics, and I am confident that we can cater to 99% of real-life situations in the field. I'll stay on this page for a quick overview before we move on. I've just presented Provision ISR's wide range of analytics, but what if you don't have any analytics set up? Searching through endless motion recordings can be time-consuming and frustrating. Our NVRs and DVRs feature a time-efficient search facility called Search by Timeslice, allowing you to locate events more quickly with just the human eye and logic. I want to demonstrate how this approach can significantly accelerate your search process in a real-life scenario. We received a request to determine when the first vehicle entered the parking lot on August 30th. Instead of navigating through endless motion recordings, we utilize Search by Timeslice feature on our NVR. Accessing the menu and selecting Search and Backup defaults the Search by Timeslice page. Here you can see the day and all the cameras listed, including snapshots indicating when the first recording for each specific camera occurred on that day. If you know the date and the camera but not the exact time, you can switch to camera mode to view all cameras. By double-clicking on the relevant camera, you can access monthly snapshots. The recording for this camera started on August the 27th. The prior days are blank. To locate the event on the 30th of August, double-click on that date to reveal the snapshots. Scanning visually can identify a car appearing at 8 a.m. but absent at 7 a.m., indicating the car's arrival between 7 and 8 a.m. Double-clicking on 7 a.m. brings up minute increments. A quick visual scan reveals the vehicle appearing at 33 and not at 7:32. Therefore, you can conclude that the vehicle arrived sometime between 7:32 and 7:33. By double-clicking on 7:32, you can proceed to playback and efficiently review the footage, pinpointing events with just a few clicks. I'm confident that you all can agree this method is much better than sifting through motion events and motion recordings. Before we delve into AI, there's one last topic I'd like to discuss with you: camera tampering and offsetting. We have two ways of receiving alerts if the cameras are tampered with. Firstly, there's camera masking. If someone covers the lens for a specific duration, we can receive an alert or set up a trigger. Secondly, there's camera offsetting. If someone physically moves or attempts to disable the camera, we can also receive an alert or set up a trigger. It's important to note that we can enable the camera tampering setting in conjunction with any smart AI analytic, allowing them to work together. This serves as an excellent security feature, safeguarding the camera against both vandalism and theft. Let's start with DDA AI analytics. It's crucial to note that DDA can distinguish between human and four-wheel and two-wheel vehicles. The analytics of line crossing and sterile area are considered basic and are available on all our ProVision ISR models. Let's explore practical applications of simple line crossing with AI filters in real-life scenarios. On the left, we have a pedestrian-only road where no vehicles are allowed. By drawing a line crossing with the rule to detect four- or two-wheel vehicles, we can alert security when a vehicle enters the pedestrian road. Similarly, on the right, we could set up line crossing at the entrance and exit of a parking lot to detect humans and notify security when someone is trying to enter the parking lot illegally. Line crossing is also effective on one-way streets to detect vehicles going in the wrong direction and to automatically open gates. By setting up line crossing at an exit to detect a vehicle, we can trigger the gates to open. A common use of line crossing is to protect wall tops or boundaries. Drawing a line to identify a human presence helps promptly notify security or response companies in case of an unauthorized entry. Concerning sterile areas, we can draw a specific area within our field of view with particular rules. For example, on the left-hand side, we've marked a no parking zone. If a human is detected inside the area, it's not an issue since humans are allowed. However, on the right-hand side, as soon as a vehicle parks in the no parking zone, we can notify security. Let's look at a case study from one of our sites in Italy, where we have set up sterile area to detect humans. Notice the sterile area box, and notice when the vehicle enters the sterile area, nothing happens. Then, when a human appears, even when the human puts on his hoodie, our AI is still able to distinguish that it's a human. And when he enters the sterile area, we get our reaction. In this case, the reaction is a strobe and siren. Let's review a few more examples of line crossing and sterile area functionality in action. To set up, simply navigate through the menu and click on Settings, then Events and Analytics, then Analytics, and lastly, select Perimeter Monitoring, which brings up our Analytics page. Here we can choose the camera and analytic type we want to set up. In this case, let's go with line crossing. Simply enable it, and now we can draw our lines. Set the rules such as schedule, duration, and determine the number of lines. It's important to note that each analytic for line crossing and sterile area can have up to 4 different zones. With line crossing, we can also specify the direction. For example, we might want to detect a vehicle traveling from left to right and ignore all other movements. Similarly, ignore humans in two-wheel vehicles from either direction, right to left. Next, we can set the detection object and adjust sensitivities. For this example, we only want to detect four-wheel vehicles. Lastly, let's customize our reaction. If we want a video pop-up, we can set it accordingly. To summarize, we have drawn a single line and established a rule to exclusively detect four-wheel vehicles crossing from left to right. We must disregard vehicles crossing from right to left, overlook two-wheel vehicles from either direction, and ignore humans. Upon the activation of this rule, we desire the video to enlarge on our screen. Let's see it in action. As a bus approaches, the trigger occurs when it crosses the line, resulting in a video pop-up. Notice that when other vehicles cross the virtual line, it turns red. However, when a human crosses the line, nothing happens. Also observe that when a vehicle travels from the opposite direction, there is no reaction. aligning with our preferences. Lastly, notice the two-wheel vehicle cross and nothing happens. Now let's switch to sterile area functionality using the same camera. This time, we define a sterile area where vehicles are allowed but humans are not. When a human crosses the road and enters the sterile area, a trigger occurs, leading to a video pop-up. Next, let's move on to our DDA second generation. As discussed, we are able to determine the attributes of an object, store that data to fine-tune and filter our search capabilities. Here is a case study of an event where a vehicle bumped into a car in a parking lot. The witness informed us that the incident occurred today, but he was not sure about the time. However, it involved a white vehicle and the brand was a Citroen. With just these two attributes, we're going to try and search for the event. So we go to Analytics Search and choose Vehicle. Select the date and choose the camera. Then we can select our event type. For this event, we want to search metadata. And lastly, we can define the metadata to search. In this case, a white Citroen. Once we're satisfied, we can click Search. The results appear on the right and we have one match. Click on the three dots on the top right of the snapshot to bring up more details such as snap time, camera name, event type, object type, and attribute information. To play back the footage, click on Playback. Within seconds, we have found the incident. We have another example with the same camera where an employee stole a roll of cable. The dispatch manager provided the following information. It was a male, wearing a black short-sleeved shirt, and the date of the incident. Returning to our analytics search, we choose the date, the camera, the event type, which will be metadata, and we're able to select our attributes. In this instance, it was a male. Upper clothing was short sleeve and the color was black. And we push OK. All the results appear, and on the second snapshot, we can clearly see a man carrying a roll of cable. By clicking on the snapshot, we can review the footage in the bottom left corner of the page. Once satisfied, we can then click on the three dots to bring up the snap details. I want you to notice the number of attributes our system captured. Observe that the system captured attributes that we didn't even search for. When you're ready, hit playback to review the incident. Check how the manager came and shouted at the would-be thief. Heat mapping refers to the graphical representation of data collected from our surveillance cameras to visualize patterns of activity and intensity in specific areas. This visualization is presented as a color-coded map where different colors represent varying levels of activity or concentration. Here's how it works. Our CCTV cameras capture footage of a monitored space over a period. The cameras are equipped with advanced analytics software that can process the video feed and extract relevant data. The software analyzes the video data to detect and track movement and activity within the field of view. This can include people and vehicles. The system then translates the collected data into a heat map, where different colors indicate different levels of activity or density. Typically, warmer colors such as red or orange represent areas with higher levels of activity, while cooler colors like blue or green represent lower activity levels. The heat map is overlaid onto the camera view, allowing users to easily interpret the data. Areas with more intense colors indicate higher traffic concentration or activity. In retail environments, heat maps assist in understanding customer behavior, identifying popular product displays, and optimizing store layouts for better customer engagement. For events or public spaces, heat maps can be used to manage and optimize crowd flow, preventing overcrowding and ensuring safety. Heat maps in office environments can help businesses optimize workspace layouts, monitor employee movements, and enhance overall productivity. In transportation systems, heat maps are valuable for analyzing patterns, identifying congestion points, and optimizing traffic management. Heat mapping provides a visual and intuitive way to understand complex data, offering insights that can be used for security, safety, business optimization, and even urban planning. ProVision ISR introduced face detection 5 years ago and has been steadily enhancing it each year. Our AI is adept at identifying and capturing faces, detecting 5 to 10 faces in each frame and sending those snapshots of the detected faces to the NVR to store. Face detection streamlines the search through extensive video footage. Users can efficiently search for specific individuals by their faces, facilitating the location of particular events or incidents. Or users can employ e-mapping to track the movement of individuals, enhancing situational awareness and security measures. Face recognition adds an extra layer of sophistication by verifying a person's identity through their facial features. This process involves comparing the detected features with a known database to determine matches. The high accuracy of this process allows for precise distinction and identification of individuals, providing outcomes of either a successful match or a no-match result. You can set up multiple databases, each with its own rules on how to react to a successful or unsuccessful match. For example, you can create a blacklist and set a rule to notify security if there is a successful match. Alternatively, on a whitelist, you could notify a salesman when their top client walks into the store. Or, in common cases, use successful matches to open an access control door. Take it a step further and use our face recognition for time and attendance or even visitor management. Adding faces to the database can't be any easier. Using our Cam2 application, you can quickly take a photo of the face you want to add or simply upload a picture from the phone's gallery. It's a powerful tool for enhancing security and access control systems. Let's see face detection and tracking in action. Imagine there's an employee facing performance issues, arriving late, leaving early, and causing distractions in the office. HR, having received complaints, can leverage face detection to analyze footage of the employee's activities. Taking it a step further, HR can also track the employee's movements throughout the day using e-mapping. To initiate the process, navigate to the menu and choose Analytics. Proceed to Face Detection, where we have the capability to search by face within this menu. We can customize our date range and select a similarity match percentage. A higher percentage yields better match results. Click on the plus button to bring up a menu for selecting the face. It's important to note that we can choose faces from existing databases or our snapshot gallery. This gallery comprises snapshots from face detection-enabled cameras that have captured faces and stored these face snapshots on our system. These stored images can be used in our searches, allowing us to look for faces not necessarily within our database. Alternatively, we can load an external face from a USB drive. In this case, the employee is Ari and is already in our database. Select Ari, then initiate the search. The results display with images, event times, the camera that captured the event, and the percentage match. Clicking on the snapshot provides a preview of the footage. while clicking on the dots brings up snapshot details. These details include basic information such as snap time, camera name, object type, and, as ARRI is on the database, personal information assigned to ARRI's profile, along with the name of the group to which ARRI belongs. We can scroll through events, and when we're ready, we can hit playback to review the footage. To track ARRI's movements via the EMAP, we navigate to the Track menu and hit play. Upon doing so, playback commences in chronological order. The camera placed on the map turns red, signifying that it is playing the footage. It automatically progresses to the next event, highlighting the respective camera. By clicking on the tracking button, we can precisely observe ARRI's movements throughout the office over the specified time period. After analyzing numerous incidents through face detection and tracking, HR utilized this evidence to address ARRI's behavior, leading to an improvement in his work conduct. Illegal parking detection utilizes DDA vehicle detection technology to identify and promptly alert to situations where one or multiple 2- or 4-wheel vehicles linger in a designated area beyond a predefined time limit. You can easily search for those events later and use them as evidence. Here is a case study involving a vehicle consistently blocking a delivery entrance. To receive notifications when the delivery entrance is obstructed, we implemented an illegal parking area and set a time threshold of 10 seconds. If the threshold is reached, our response is to activate a siren. As the vehicle enters the designated area, a countdown begins. It's important to note that the clock on the screen is for graphical representation only. Initially, the vehicle does not meet the 10-second threshold. However, when it re-enters the area and surpasses the threshold, the siren is triggered, notifying both the driver and security of the blocked delivery entrance. We can search for illegal parking events on our NVR by going to the menu and selecting Analytics. We can choose our date or our date range, select our camera, and lastly, choose the event type, in this case, illegal parking. Clicking on Search brings up the results. From here, we can access more details about the event by clicking on the 3 dots. Notice the basic information provided with each snapshot. From here, we can also play back the footage. Similar to illegal parking, loitering detection utilizes DDA human detection technology to identify and promptly alert to situations where an individual or multiple individuals linger in a designated area beyond a predefined time limit. Just like illegal parking, you can easily search for these events later and use them as evidence. Here is a case study of workers taking a break in the parking area, obstructing vehicles entering and exiting. To address this issue, we implemented a loitering area, set a time threshold of 15 seconds, with the trigger being an audible siren to alert the smokers of their violation. When the person enters the designated area, a countdown begins. Again, it's important to note that the clock on the screen is for graphical representation only. If the person exits the designated area before the threshold is met, nothing happens. However, when they re-enter the area, the countdown begins again. Also important to note that when a second person enters the area, a countdown begins for them. Therefore, each object has its own countdown. Now the threshold is met for the first person who has entered the area, and the siren activates, informing them that they violated the company policy by loitering in the parking area for too long. We can support loitering events on our NVR by going to the menu and selecting Analytics. We can choose our date or date range, select the camera or cameras, and lastly, choose the event type. In this case, loitering detection. Clicking on Search brings up our results. From here, we can access more details about the event by clicking on the 3 dots. Notice the basic information provided in each snapshot. From here, we can also play back the footage. The Advanced Audio Exception Analytics empower the detection and response to changes in sound levels, whether above or below a set threshold, occurring for a specified duration. Instances of heightened sound changes may include occurrences such as gunshots, motorbike sounds, dog barking, or situations in noise-sensitive environments like hospital wards, where monitoring noise levels is crucial. Conversely, sudden reductions in sound levels below a predefined threshold within an industrial setting could signal equipment malfunctions or failures, triggering immediate maintenance alerts. As this analytic is relatively new for ProVision ISR, I don't have a practical scenario in real-life situations to show you. However, let's explore the principles of how the audio exception feature functions in one of our cameras. Take note that we have the option to employ the built-in microphone of our camera or an external microphone when utilizing one of our cameras equipped with an audio input. This offers flexibility, eliminating the requirements for the camera to be physically present in the room it monitors is this analytic. Upon entering the camera interface, there is a section dedicated to audio exceptions. After enabling it, we navigate to the part that displays the sound of the current environment, which serves as our baseline. From there, we can choose whether we want an alarm triggered by the camera, and we can specify whether it should respond to a sudden increase or decrease in sound. For this example, we'll select increase. Depending on the environment, we have the flexibility to adjust the sensitivity threshold setting, recognizing that each environment and situation is unique. Once satisfied with our setting, we save them in the configuration box. If there is a sudden spike in noise level beyond the specified threshold and duration, an alarm will be triggered. Similarly, when detecting sound decreases, we simply choose a sudden decrease in sound and apply the same principles. In our analytics discussion, we now turn our attention to the critical aspect of triggers and response to events. As a standard feature shared by all our competitors, we have the ability to pop up a video, send an email alert, push notifications to our Cam2 mobile app, record or capture snapshots, and activate alarm outputs on both the NVR or DVR, as well as the camera that detected the event. What distinguishes ProVision ISR is its unique capability to trigger multiple or all available outputs within the system. This extends not only to the camera that detected the event and the NVR alarm outputs, but also encompasses all cameras with available alarm outputs, and even our USB alarm I/O expanders. Additionally, with PTZ cameras, we can configure any of them to move to a predefined preset. All of this is orchestrated based on a single camera's event. This approach exemplifies our commitment to providing a versatile and integrated method for event responses, thereby enhancing security and surveillance. Despite the array of options, you might assume that setting them up is complicated, but in reality it couldn't be easier. In our NVR as an example, once you're in the Analytics Setup menu, all our analytics provide the option to customize triggers. After defining your analytic rules, simply navigate to the Trigger menu. Here you'll find all the reactions I've just demonstrated. Witness how effortlessly you can customize your reaction. Simply choose the cameras you wish to record. Proceed to the trigger alarm out and observe that you can select any combination of available alarm outputs from both the NVR and the cameras. Finally, you can also set presets for the PTZ cameras. On to our last topic, combined alerts. But what exactly is a combined alert? The concept behind it is to combine two events, which could involve a combination of motion events, sensor inputs, face recognition, or events associated with our DDA sterile area or line crossing. For the system to initiate a reaction or trigger, both events must occur simultaneously. The reaction or trigger for this response can be customized for each combined alert rule. This implies that if you have multiple combined alert rules, each one can have its own personalized trigger or reaction. I've compiled a couple of scenarios that I believe most of you can relate to where combined alerts prove useful. So let's take a look at them. In this scenario, we've implemented license plate recognition that activates a boom or gate to our property. While this offers convenience, setup may be less robust security, considering that license plates can be cloned or stolen vehicles may gain unauthorized access. To enhance security, we can implement a combined alert rule that pairs a successful license plate recognition match with a successful face recognition match. This means that the gate will only open when both the license plate and face are authenticated together. Another scenario involves a fascinating request from one of our European clients who had an existing license plate recognition for egress into a property. However, they wanted to monitor the temperature of electric vehicles to deny access if the temperature exceeds certain limits. By deploying our thermal camera, we combined the existing license plate recognition access control with temperature monitoring. The process works as follows. The license plate must be on a whitelist, and concurrently, the vehicle's temperature should be below a predefined threshold. Only when both criteria are met will the boom permit entry. The following example are for areas prone to frequent false alarms, whether due to environmental factors or challenges with animals. The solution is to combine an alarm sensor with a human detection-enabled camera, specifically utilizing sterile area or line crossing to minimize false alarms. The sensor must detect movement and concurrently must identify a human presence before triggering the alarm. An additional benefit is that the client can also receive video verification of the alarm activation through his Cam2 application. That wraps up my presentation. I hope you found it interesting and gained valuable insights into the world of ProVision ISR analytics. If you have any further inquiries or would like presentations on our Solutions VMS or Cam2 application, please don't hesitate to reach out.